Good morning, everybody. Muhammad Raja, how are you?
Good morning, good morning. Fine, good.
Good morning, Raja.
Good morning, Dr. Said.
Good morning, Muhammad. I was helping Naja to install the ISIS. I share many files with you. Did you receive it now on WhatsApp? Raja Muhammad, did you receive the files on WhatsApp?
Yeah, I will check, Doctor. Yeah, I will check.
Raja?
I have received the files. I received it.
Naja,
Yes, yes, please.
good morning. Take your time. Naja, can you make it mute, please? Okay.
Good morning, Kishore.
Good morning.
Hello.
Yes. How is going? Is it hanging now? Is it going like crazy on your laptop?
Right now, it is like that status only. It's at 20 minutes. After that, I'll check.
Okay, perfect. Okay. Let me start. Let's start the today training. What I received from, I will close just 1 minute. This one. Okay. Let me share this one. Muhammad, do you remember this?
Yeah, disappear.
Yes. That's what we received from Muhammad. Now I am speaking with through the piping discipline. I am the piping discipline now. That's what we're receiving from Muhammad as a BNID to be installed in our 3D model, BDMS, and or on Navisworks or AutoCAD 3D, whatever software you are going to use. We didn't know the piping diameter, we didn't know the piping name, we didn't know the control philosophy here, how it is mean, we didn't know the isolation philosophy, how it's going to be done. Simply, what we received is very generic BNID. We need more detail on how this equipment is going to work. You get my point, Muhammad? I'm speaking now, piping point of view.
Yes, Doctor. Just the screen is black. There is nothing that I can see.
Is that everyone?
Yeah, same for me. Yes, the same for me also. Yeah.
Is it the same black now?
Yeah, it's okay now. Yeah.
Okay,
Thank you. It's okay. Yeah.
perfect. Keep me updated, Muhammad,
Yeah.
if it is screen is going black for any time.
Yeah. Thank you.
Okay, that's what we received from your side, right?
Yes. Yeah.
Okay. Now let me speak like the piping engineer is going to do when we have internal weekly meeting inside the EPC companies. This is a generic PNID which we received from your side, Muhammad, as you are process engineer. We as a piping, we didn't know the pipeline diameter, we didn't know the fluid characteristics, we didn't know the control philosophy you are going to apply, and we didn't know the name of the pipeline. Even the vessel dimensions we didn't know till the moment. So what we are going to do today is to continue hydraulic, to continue issuing this P&ID as a typical one, discussing how we going to make isolation philosophy, making the layout better for us, to discuss with the piping engineer and see how the piping engineer arrange and take care of this work, arranging the equipment inside the plant to maintain minimum piping between equipment. Okay.
Excuse me, doctor.
Tell me.
Can you please tell us how many philosophy that we need to think about when we just like design PFD or PID? So,
You tell me.
sorry.
You tell me which philosophy you worked with before.
To be honest, and the philosophy that I just like I'm still confused about it because is it something just like guidelines that every company should follow, or each company has its philosophy? What is the philosophy itself? Yeah, how can we think about it? And how many? For me, for example, I can say just like some of them, just like control philosophy that I know. For example, I've heard the draining philosophy, but how many philosophy that we can just like sort them out all in one, just like time that we need to follow, so it will be clear for us. So we ensure that we will not miss any when we design or doing something, please.
Okay. These
Thank
are
you.
very good questions. Are you opening from your WhatsApp, or from your mobile, or from your laptop?
From my laptop.
Perfect. Open the chat between me and you, on the group. You will find process engineering module. I will share it here because it is a little bit big one. So I will open it in small portions. Here we are. Do you everyone see my yellow screen?
Yes, thank you.
Okay, let me speak. Engineering philosophies are design philosophy, which is coming from the basis of design, where we said that we are going to follow ASME code, API code, best practice, whatever codes we are going to do. Then we have a different philosophy for different phases. For the construction philosophy, where your input as a process, I am taking it from Abu Muhammad, and then we will go for each one on specific. Okay. The point for this course is the design philosophy, but I will make it bigger now, so we understand how it's worked for a life cycle of the project. Design philosophy, which is maintenance philosophy, the isolation philosophy, the pressurization philosophy, and all of this. We're coming to take it deeply. But let me go through all the philosophy, then back to the design. Construction philosophy is how we are going to construct our plant. Are we going to install the equipment side by side? What about the delivery time about the equipment? which equipment we are going to ask the workshop to fabricate first, and based on what, which critical equipment we need to convince our client that we are on track, how we are going to interfere with the planner, the schedule man who is going to make this philosophy. This is the construction, the commissioning philosophy, how we are going to commission this equipment. Is there any particular needs we going to use? Are we going to hire nitrogen trucks? Are we going to hire demon water trucks? Are we going to hire extra labels? Whatever. All this was going to the commissioning philosophies. There's a lot of needs in the commissioning phase. Are we going depending on a black startup, which there is no gas on all the plant? How we are going to depressurize our plant or pressurize our plant? Operation philosophy, the way of the operator thinking in how he is going to operate this plant. Operation philosophy is simply another way of the manual operation manual. How the operator, how the shift engineer will operate his unit, how many modes of operation he have, what is the startup procedures, what is the emergency procedures, what is the troubleshooting procedures. Safety philosophy, most of the cases coming with the depressurization and the radiations and the amount of energy or heat coming out of the flare tip, and specifically about the quantitative risk assessment, how we are going to work with the risk inside our plant and outside affecting our neighbors. That's coming under the QRA, which would be very, very, very effective on this safety philosophy. Then we have the contaminated philosophies. This is especially for the offshore one. The offshore one, what happens if we have a pipeline rupture, subsea pipeline rupture? How we are going to contaminate it? Are we going to install mini isolation valve across the pipeline, or how we are going to tackle this one? That is overall the philosophies which we have on a life cycle of a project, Muhammad. For the B&ID,
Thank you.
I didn't finish, don't worry, we still have a lot of things. For the B&ID, for the design philosophy, we still have. Let me go up. What is it? Okay. Look, not still. 1 minute. Okay. Look, Muhammad. Here in the feed, we define the control philosophy. Control philosophy. When you go into the detail, we identify the relief and blow down philosophy, protective system including fire philosophy, then produce safety and environmental case. Not interested in this part. But here's 3 philosophy you are going to use. This all? No. Let me search for other philosophies for you. Major equipment design philosophy, where we have selecting the 3-phase separator or the descender in our case. Then we have the preliminary layout drawing, and the philosophy for spacing about this. This until now 5 philosophy we are going to use. Then let's go to the here startup, commission and handover, where we are having the commissioning philosophy. This means, Muhammad, during the process design we have 1, which is the relieving philosophy, 2, blow down philosophy, 3, control philosophy, 4, which is the equipment design philosophy. That's all? No, we still have the, it is not listed here, we still have the isolation philosophy, and the what I shared with you was like, okay Naja, give me 1 minute and I will back to you. Then we have the plant layout philosophy. If you can see, let me share this one. 1 minute. Let's start to tackle one by one, Muhammad. So I will start with the isolation philosophy. Your BNID, Muhammad, which you send it to me, which included the descender and the 3-phase separator. What was your isolation philosophy for isolating such equipment? Let me ask this on another way. What is the philosophy of isolating this equipment? Why you need to isolate this equipment?
I think mostly for maintenance purposes.
Totally right. Do you see this my screen now?
Yeah, thank you.
Can you read this one?
So, starting from this section?
Yes. Everyone
Okay.
focus with Muhammad, please.
Isolation philosophy. This section details the methods to be used in making a provision to completely isolate equipment or sections of plant to permit safe operation and to provide access for maintenance and inspection. Process sections shall also be isolated for leak testing during commissioning. The design guide shall apply to process and utility systems, including packaged equipment. In general, it must be possible to isolate all equipment separately or commonly within a process system, except those systems in non-hydrocarbon service, where it has been established that a hazardous condition will definitely not exist. Isolation shall be accomplished by the use of block bulbs and/or the insertion of spectacle blinds or spades, or the removal of spool pieces, and the installation of blind flanges. Location of isolation to enable maintenance and inspection is generally dependent on the hazardous nature of the contained fluids, the pressure rating of the piping system, and the extent of shutdown.
Naja,
Yes.
can you
Yes,
see?
sir.
Did you follow what Muhammad said?
Yeah. Yes.
Okay. Let me share this screen with you. I just search for it. Why it is not here? Okay. Is everyone seeing this white page?
Yes, doctor, yes.
Yes.
Okay, now we are going to understand how we are going to apply this isolation philosophy. as Muhammad mentioned before. The question is, let's start with a normal tank. This tank is going to be, or simply to have, person here for internal inspection and maintenance. The tank Muhammad Naja is almost half. Here nitrogen blanketing, here is the feed, here is the output to the pump, whatever it's going to do, and here is the vent to atmosphere. It is the atmospheric one, and we have here hydrocarbon condensate. Let's say condensate is coming inside the tank. Muhammad.
Yes, doctor. Yes, doctor. Yes.
If you are going to be the person here,
Yes.
what you need to go inside the tank?
Should manual, you mean?
Yes, it is a
Just like,
simply it is a confined space.
yeah. And
Confined space to enter.
I mean, talking about the safety measures and precautions.
Yes, tell me the safety and precautions you need.
You will need first, if it is hydrocarbon, just like to after you empty the tank, you need to just like purge any gases inside it, and do gases tests from time to time to ensure that there is no gas inside the tank. And you will need just like a lifeline to be just like tied to the person, just in case if there's any problem. What else? Yeah, and the most important that to isolate the tank from inlet and outlet to ensure that no, just like fluid will be entered during the inspection and maintenance test.
Thank you.
Thank you.
This is the most important one. We take care about it in the design. The question is to put someone here, BB, British Petroleum. Well, if you are working with the British Petroleum, they will not allow anyone to enter the tank without, after isolation and empty and purge and all of this. The type of isolation they are asking for is double plug and plate. That's the kind of clients we have today. If you work for Saudi Aramco, let me just clarify the difference between customers, and then we will speak. If we work for Saudi Aramco, they will ask you if you have a one valve, then we have a spectacle blind about it. This one will be the blind side, and this will be the open side. This is the type of isolation they can accept. BB ask for valve, then we have the blade on it. Close, open. This is BB. If you work for a shell, Shell Egypt, for example, they will ask for one valve, spectacle, then a removal spool. What's mean removal spool? That means this amount of piping, this part of piping is you design it on a flange basis. Make a flange here and a flange there, one flange here and second flange there. So when there's one going to enter, they close this valve, they switch it to the back side, then they remove this piping spool as the inlet of the tank. Is this all? No, for all the tank connections. For BB, they asking for this. For Aramco, they asking for this. For Shell, they asking for this. The question, Muhammad, and you Naj, and you Taj, what is the difference between all of this? I need answers. Hello?
Yes, doctor, yes.
Tell me. All of them are simply isolation philosophies, isolation connections. The good question is, are all of them doing the job? Yes or no?
So comparatively, if you look
Yes.
into the shell, it is much better than the other things, other procedures.
Shell?
Yeah, because they are removing the spool.
Yes.
So the chance of any flow is totally nullified.
Your voice is too far.
So when you look into the shell, so they want the spool to be removed.
Yes, you're a big speaker on this one.
Yeah, spool to be removed. So the chance for any flow here it is totally becomes zero. So since the spool is removed, for human error, the possibilities are less since the spool is being removed. Whereas in the other cases, the valve can sometimes be let open, or the insertion of the blind can be sometimes it may be forgotten. There are some chances.
For Aramco?
Aramco, I am just new to this. I'm not
BB.
I'm speaking about British Petroleum.
Shell. Is that what you're speaking about?
Yeah, I'm speaking about Shell.
This is a good one. This is a good one. This is a good one. All the three are good. Depend on the application. Depend on what? Application. Without understanding the application, you are totally missed. What does this mean? Let me bring a new one. Oh, not a lot. No, thank you. Sorry, I just... Deleted. Please deleted. Do you see it is empty now, right?
Yes, doctor, yes.
Okay, let's... where is it? Disappear again. Okay. If we go to work with BP or Aramco or Shell, first of thing, what they are interesting that you have is BB technical library. Everyone have received his equipment, his list of library. You receive what all the person have as a philosophies. You receive what BB is doing, what Aramco, Saudi Arabia, right? No one is replying to me. Hello.
Hello, Doctor. Yeah. Yeah, we received such a document, but I'm just not quite sure because I didn't just like search all of them. But BB, to be honest, not quite sure if you send it, please, or not. You can't just like confirm. Other guys can't confirm this or not, please.
What I send is Saudi Arabia, Person, Qatar Gas, ExxonMobil, Total, Foster Wheeler. I didn't send PP, right?
Yeah, yeah.
Okay, let's see any one of them. Okay, let's share what we have in a person, for example. All the person as a this is the isolation guide for Wally Person for system valving and isolation. Everyone see it?
Yes, Doctor. Yes.
Okay. That's what we are receiving. You receive as a client if you hire Wally Person to work with it. There's a lot of isolation schools for positive isolation, high integrity isolation, or general isolation, or high low pressure isolations, which exceeding more than 20 bar G, which mean that if we have, let me go back here, if we have a high pressure, low pressure, we have a high pressure vessel is going to send liquid to a low pressure vessel. Which type of isolation we need it? We are depend on a single valve or double isolation valve or spectacle one or whatever. If we have H2S more than 300 ppm, what we are going to do? Here is the typical methods for isolations. Positive isolations, which is you can remove a spool, make a spade and spacer, or you make a spectacle plug. High integrity isolation can be double block and blade, as this one, two valve in one body and blade, like this configuration, or integrating double block and blade in a single valve. This is a new one. Or and focus on or, because this is what we are going to install on all the normal vessel. When I speak about normal vessel, we are speaking about vessel which contain hydrocarbon below 1000 psi, which is have a normal isolation configuration like this one. And this vessel which operating in 1000 psi didn't have any human entrance. Person will not entering inside it. If we are going to go inside it, we have to make double block and blade or a spectacle blind. Okay. This is what we have different from BB and Wally Person. This table. In BB, if you have, or let's start with Wally Person, you will go for a positive isolation, which will be like double block and blade. If you are higher than 20 bar G. In BB, you will go for a positive isolation if it is higher than 10 bar G. In Saudi Arabia, you're going for a positive isolations, which will be like this phase, this arrangement. If we're going higher than 15 bar G, shell 12 bar G. Why we are speaking these methods? Because by the end of the day, this double block configuration will cost you a lot of valves, which will impact on your project budget. So if you're going to have a project with Shell, or you have a project with BP or Saudi Aramco, you have to consider the isolation philosophy you are going to use during constructing your P&ID, because based on that you will have a lot of valve, and especially if you are ABC contractor, so you have to make sure that which isolation philosophy you are going to proceed, and all the other philosophies like equipment philosophies, like sparing philosophy, and we are going to speak about all of this now. Okay, here is limit of use of spectacle blind or blinds or spacers removable spool. If we have a pipeline which is 12 inch 25 millimeter equal to 2 inch, and 250 is equal to 10 inch, and here is the rating for the piping. 150 is going for the flare, 600 is rating can reach to 1440 BSIG, which is the most common for us to work in this section. This give you when we can use a spectacle blind and a space and spectacle or removable spool. If you are going to speak with, or you're going to have equipment which operating at rating of 600, and you have a pipeline of 10 or 12 inch, then you can use a spectacle blind very easily. This table come from ASME P31.3, where we can use the flange rating, ANSI and ABI flange rating. We are here speaking about standard spectacle blind, not the one you can fabricate in your workshop. I insist on this. Here we are speaking about standard spectacle blind. This means if we're going to higher pressure, we going to jump, or let's go to higher diameter, then we will go beyond this curve, then we will need a spade and spacer or removable spool. This is one of the requirements by the piping. Okay, that's more than enough here. Let me back to my white page and start to draw the first equipment for us, Muhammad, which you sent before.
Okay, doctor.
Okay. Let me check what happened on the WhatsApp before. Naja,
Yes.
click on one on as Aspen One Engineering.
Excuse me.
Click on Aspen One Engineering.
Okay. In the Aspen One Engineering. Okay, fine. I'll click. Then
You have to select Aspen Heises as a product, because Aspen Tech have a lot of
Okay.
products. Once
uh-huh.
can you just
Okay.
share share your screen?
I'm in a different computer. I'm working in other room, so that's not installing in this computer. So I will do that from there.
Okay, just keep me updated on WhatsApp, okay?
Okay, fine.
Okay. And focus also. Because we're going to draw the three-phase separator which we have in our plant. You want me to draw it or just to make it? Okay. Everyone see my white page, right?
Yes, doctor.
Okay, perfect. Let's start to draw the three-phase separator. Here is the inlet line. Here is the outlet line. Here's the feed. Here's the gas. Here's the condensate. Here's the water. The first question we are going to ask Muhammad: are we going to enter this separator? Is there any kind of human to go inside it for cleaning? Muhammad, you have to answer me.
Yes, doctor. So for cleaning purposes, so we need to make someone to enter the vessel.
Yes, that's my question to you. Is that
Yeah,
is
so-
that a normal activity in your plant? To stop the separator, to stop the tower and make someone enter?
Yeah.
Okay, Naja, complete on this. Perfect, Muhammad. So,
Okay, this is
yes, tell me.
uh, this Aspen. So it is automatically asking certain ticks like Aspen films. This is required or
No.
pipeline?
No. We need Aspen Heises only. As you make Aspen Heises, already Aspen Plus and Aspen Heat Exchanger and economical evaluation and basic engineering installed. That's what you need. Because making all this package will ask for another crack. We are not interested in here. Just keep on this. And focus with us, please. I know it is hard, but you need to focus here.
Okay, sure.
Okay, if we are going to make this plant in Muhammad facilities, in Muhammad companies, we will have someone here. That means if we have someone here, confined space entry, Muhammad companies, like say Saudi Aramco, will ask for Muhammad. I just speak about isolation philosophy till the moment. Muhammad
Yes,
company will
doctor,
ask
yes.
for one valve, then a spectacle blind. Here we are. That's not right. Closed side is now the valve is open and the spectacle is open. Here is the one configuration. The same configuration we will draw it here. Spectacle. This one will be closed. Then we have the valve. Spectacle. This one will be closed. Then we have the valve. Spectacle. This one will be closed. Then we have the valve. That's what we did as isolation. till the moment of Muhammad, we didn't do anything related to process. We simply put this as isolation philosophy required by the client. We have here one valve. It will be ball valve, ball valve, ball valve, ball valve. All the ball valves is coming with a spectacle blind, spectacle blind, spectacle blind, spectacle blind. Why? When we need to make this person here, we simply will cut the feed, then we depressurize, through the pressure safety valve and the ball valve. We will going to use this one to depressurize all the pressure here inside the separator. Then we are going to dump all the condensate or all the water, depending on what you have here or there. Then we will close this valve, close this valve, close this valve, close this valve. Then we'll ask the mechanical guys to switch the spectacle to the blind side, here and there, all the four sides. Then open the manhole, purging, and make sure that the gas is good. Then anyone can enter. Right, Muhammad?
Yes, doctor.
Is that good till the moment?
Yeah.
Okay, let's open the real B&ID and see how they're doing it. Let me share the B&ID, actual B&ID, which we have in your... Yes, this one. Is that what you have on your screen now? And that's what you have on your B&ID?
Yes.
Here is the inlet from the descender. Then we have a valve and a spectacle to the open side. You got it? You see this one?
Yes. Yeah.
This is the inlet line.
Just a quick question, please. Why do we need to put the spectacle just like in one side, when to the inlet and to the other side? I mean, is this strict to put the spectacle blinds in this position, or you can just put it either in the beginning of the face flange in here or here?
You mean this spectacle will be on this side?
Yeah.
Let me understand your question. Good.
Yeah.
Here is the
just like
spectacle.
as you understand. Yeah. So is it necessary to put it this side, for example, to the inlet, and the other side for the outlet? Or it just like comes as it is?
Let me give it to you as I learned it. We put it on the equipment side.
Yeah.
The question is why?
Yeah.
Because what we are going to do, what is the intention of installing this spectacle or this spectacle here? Let me just... Why we need this spectacle here?
Yes.
I just make it smaller. And why we need to make this? Where is it? Okay, this is 1, 2, 3. The good question is, what is the purpose of the spectacle? You answer me, Muhammad.
To isolate the system to be maintained from the other section of the plant.
Perfect.
The line.
Perfect. Where is the flow direction? This side, right? It's coming to the
Yes.
flow is coming from here, going out here, going out here, going out here. So if we install, here is the valve, and we install the spectacle on this side, the question is how we are going to stop the flow to open this flange to make the spectacle swap or switch. The flow didn't stop, right? Right?
Yes, doctor. Yes, doctor.
So in this case you need to close the valve first, then after it you install the spectacle, so you can depend on the valve isolation and switch the spectacle blind. But if you put it here, there's no isolation on the feed which is coming on your way. The feed direction make everything for you. Here we want to isolate this equipment and switch this one. If we put this spectacle on this side, on the feed side, you will not be able to switch it until you stop the feed, which in many cases this will not be required. You can bypass the separator or doing anything else. So what you want to do is make sure that this equipment, the person here, didn't have any hydrocarbon in his face. So you need to isolate the equipment. Tell me, Muhammad, what you want to say.
Yes, doctor. Yeah, I understand. Yeah, thank you.
What?
Doctor,
Yes.
yes, understand that still it contains pressure upstream side, still the energy is there. So you cannot possibly deflange and insert the blind because already pressure is there upstream side because the flow is okay. One more question is that this blind is installed downstream of this isolation valve. Why not near the vessel itself, vessel flange? Like this one, you see there is a downstream FC and there is a FC. And finally, there is a flange near the vessel. So that why can't be there?
I love your question.
Yeah.
It is a different schools. Some different schools. There's no standard for it. Take care about what I am saying. Some people, if they want, for example, to make a maintenance or a function test for this shutdown valve, if this valve is here as you want, if this valve is here, this one will need additional manual valve upstream and downstream for maintenance purpose. The same configuration as here. Here's valve upstream, here is valve downstream, and here is two valves on the bypass. Hamad, everyone,
Yes, doctor.
please, everyone on this course, please focus on this configuration. This configuration is a copy and paste configuration for all the control valves. Here is the control valve, here is a manual valve upstream, a downstream, and manual valve upstream. Then we have the two different manual valve on the bypass, and here is one vent. The question for you, Naja, moving this one here will cost you another manual valve here to make sure that you can isolate this SDV in case of maintenance. So you will need one valve here, and there's already a manual valve downstream of this shutdown valve. So installing this here will save one valve on your side. Let me draw it in. You got it, Naja, or I will explain it more? You need more explanation, I think. Let me,
Yeah, little bit more focus. Yeah.
yes, let me go for a new one. Did you see my white screen, right?
Yes.
Okay.
Yes, sir.
Here is the vessel site. Here is the pipeline. Okay, just 1 minute. I will make it 2 visit sites so you can compare. What he was doing is, we have a manual valve, we have a spectacle, then he has the ESD valve, and he has the control valve. The same configuration here. We will put it, but we will put the manual valve as you want to be here. The control valve is normally coming with the manual valve here. Is it clear, Naja, now?
If you want to shift the isolation valve downstream, that's what you have done. For example, keep the isolation valve same place where the top one, and only blind vessel. Near
This
the
one?
vessel.
Move
If
it
you
here.
keep Same like top side, isolation valve upstream of ESD valve, and only blind shifted to vessel side. In the configuration,
You want just to move the blind only, right?
only blind only, yes.
This configuration cannot be separated. You cannot make a blind only here. You have to have a valve upstream of it. It is a must. The question is why? Because if all this valve on the line is passing, you will end up by that you don't have any spectacle. This spectacle, you will not be able to rotate it. It should become with a valve. On the other hand, if all this valve is passing and you have only one valve is working, you can close this valve, switch this one, and you can maintain all these ones, all these valves. On the other hand, here on the bottom, if this valve have any problem, just need a complete shutdown. If this valve have any problem, we can use this one and maintain this one. But
Yeah, agreed.
to make sure that this one will not cause you a complete shutdown, we simply take this one from here and install it here. By installing here, look to what we are trying to do, Sajid. By installing here, Then we have one valve close in case if we want to any human entering here. If there is someone who is going to enter, we will close this valve. We will switch this spectacle. We will close this shutdown valve. We will close this manual valve. We will close this manual valve. We will open this manual valve, and almost all these bypasses are closed. Then you have this man. You secure him with 1, 2, 3, 4 valves on the way. The same configuration here, we have the same 4 valves, but the ESD functionality or function test or malfunction will cost you a complete shutdown, and this will affect your reliability and the, on another word, availability of the plant. And in this case you can go to penalty between the EPC and the owner, because the owner will ask for availability, let's say 97%, which in this case, if you want to achieve this 97%, you will need to install additional ESD valve. You get it or you didn't get it. Just ignore this availability part. Before the availability, did you get it? For the ISO spectacle here and there.
Yeah.
The availability part is what we agreed with the clients. You need your plant. It is like 365 days running. This is the years. If you're going to make availability of 97%, this means this plant is going to shut down for 18 days per year. This 18 days should have all the preventive maintenance for all the equipment, including the downtime for the shutdown valves. So if we need to keep this 18 days, in this case we will have to install another shutdown valve here to make sure that in case this fail, we have another pass for the flow. This is regarding the availability and how much running time we want. This is high example on how many pumps we are going to install inside the plant. When you're going to the pumps in our plant, we are doing in model compression, we are speak about availability and why we're using 2 pumps instead of 3 or instead of 1 pump, and we are going to speak about this on a specific way. The question is, for the maintenance philosophy, isolation philosophy here, we finish this part regarding the spectacle and double block and blade and isolation for the equipment. Let me go to share the real BNID which we generated and take your opinion about a lot of things. when we selecting this one, let me move all this 1 minute. Okay. Here is the line coming from the descender. Then we have the manual valve, pole valve, we have the spectacle, then we have shutdown valve, then we have a flow control valve, then we have the separator, then we have another shutdown valve, then we have a level control valve, then we have another level control valve. Naja, the question for you,
Yes.
why we have a shutdown valve here to my mouse and another shutdown valve here to my mouse?
Okay, there are two shutdown valves. Fine. Then
Why we have two shutdown valves? That's the question.
interlock.
Muhammad,
The
Yes, doctor.
I miss your voice. Why we have a two shutdowns valve here?
possibility.
Yeah, for safety purposes. Can you just please make it closer on the shutdown valve section, please?
Here is the shutdown valve, and here is shutdown valve. Number 4 and number 6.
The first shutdown valve is to protect the vessel. This vessel V201, and second one to protect the compressor and upstream equipment.
Protect the compressor.
Uh,
Good and no. Yes and no.
Whether low pressure in this vessel can affect this integrity, then the addiction. Or downstream also have downstream in case of sudden isolation for the downstream compressors. This compressor, I don't know what is the zoom or machine. If it also says, then it will close.
Totally right and totally mistake. Let me clarify something here. No, sorry for this, but I am trying to cover the other side. Let me put it here. What I am going to draw now, Muhammad, Naja, focus with me. This is coming under the depressurization philosophy. Here is the feed coming. All the gas, all the condensate, all the water. First, we have the first big ESD on the boundary limit. Boundary limits, by isolation philosophy, it must have ESD. Take a note, everyone, please take a note on this. Boundary limit must have ESD. Then we have a descender where we are going to flash with water, and all the coming will have then entering to a three-phase separator where we install another ESD here at the inlet. Then we have another ESD at the outlet of the gas. Then we have the compressor where we have another ESD at the outlet. Then we have the liquid condensate, install it on the surge drum. We have ESD as the outlet, then going to the pump, and from the pump it is mixing with this line, and from this line going to the ship line or the network. Okay, how many ESD we installed? 1, 2, 3, 4, 5. Why we install this ESD like this way? This is called sectionalization. Why we need to make a sectionalization for the plant? Why we are dividing our plant to sections? This is common, Muhammad. This is common Naja for any plant. Small oil plant till a big petrochemical company. The same configuration is running. Cause what happened in case of fire? Here we have a fire, and we need to evacuate all the gases, all the hydrocarbon inside this plant to outside, to the flare. We are going to use a blow down valve. Blow down valve to be installed here. Blow down valve to be installed here, and there, and here. So we have a blow down valve here. 1. Blow down valve 2. Blow down valve 3. Blow down valve 4. What is this? What's blow down valve? It is a ball valve, basically. A ball valve. We will learn how to make this calculation on HYSYS, but I just want to make sure that you are following the philosophy. Here is the ball valve. It is coming with a signal from the control room in case of fire. In case of fire, this ball valve here, here, and here, and there will open to the flare header, and this ESD will close, right? Everyone following me? Muhammad?
Yes.
Yes, doctor. Yeah.
This is the most important part. This is the way we are thinking. Now we have this ESD close. This blow down valve is responsible for blow down all the piping here and vessel here and all this piping through this blow down here till the flare header. You got my point, everyone? This blow down valve is responsible for this inventory, starting with this flange when this is closed and ending here. All in between is responsible by this blow down valve to flare to the flare header. All this gas will go to the flare header. Everyone get my point or no? Yes or no?
So, doctor, you mean just like the section between the downstream shutdown valve and the
One
upstream one
and
will be just like drained to the vented to the flare.
yes, not drain. It will be going to the flare.
Vented, yeah, gases,
Yes.
yeah. Thank you.
Why we are speaking about this one now? Because if you look to any of your plants, any of your plants, you always will find the number of ESDs is bigger number of ESDs valve ESDs valve bigger than the blue down valve by 1. Look to your plant, Muhammad, and tell me any equipment in your plant, any portion of your plant, you will find the number of ESDs higher than the number of blue down by 1. The same for you, Naja. Look to any BNIDs, you will find always the number of ESDs higher than the blue down by 1. This is the rule of thumb. Why? Because as you see, this section need 2 valves, ESD valves and 1 blue down. This section 2 ESD valves and 1 blue down. This section 2 ESD valve and 1 blue down. This section, the compressor section, 2 ESD valve and 1 blue down. So always remember that the blue down is used to remove or flare the gases between 2 emergency shutdown valves. That's called sectionalization of your plant. The question is why we are following this philosophy, why we are doing this one. Because when we are trying to size this blue down valve, sizing process, take care about what I am saying now. It is a sizing process. This means we want to make calculation for the blue down valve. We have to define certain inventory between. We can take this vessel to vent it through this blue down, but the problem is what is the maximum for this vessel? When will this blow down? Which capacity we will take? That's why we need to define the inventory and make a limit for each inventory. Take care about this one. Make a limit for each inventory. Why? Because if we didn't make a limit, we will not able to make a calculation for this blow down valve. That's why we make sections. We will say that this section here from this ESD till this ESD is going to be section 1 and going to be flare in case of emergency, in case of gas leak, fire leak, through this blow down valve. This section starting from here till end of here will go through blow down number 2, and based on that, take care of this. Based on that, we are going to say this blow down, for example, will be sized for 4 inch, 6 inch, 8 inch blow down valve to take all the volume here inside the vessel and all the piping related to this vessel till you reach to your boundary limit, which is the ESD. You got it?
Yes, thank you, Doctor. Thank you.
Naja.
Thank you. Got it.
Okay.
So, Doctor, sectionalization comes just like in within the, for example, fire prevention philosophy, or it is just like a separate or independent section in terms of philosophy, the sectionalization.
Sectionalization is coming under the depressurization philosophy.
So it's just like independent philosophy.
Let me
It is not
clarify.
related to any.
Let me clarify.
Yeah, thank you.
What we are going to do is, here is the ESD valve close, here is the ESD valve close. We need this inventory to go safe to the flare. So we define the blow down valve for in case of emergency. We also define the pressure safety valve in case of failure of this blow down valves. In case of failure of this blow down valve, we added another pressure safety valve here. The question is, this is coming under which? Under depressurization philosophy. Which mentions that are we going to make this one, this section, in case of emergency, depressurize according to what? Through the blow down valve or through the pressure safety valve, and which time we are accepting during the depressurization process. The main factor we are going to discuss as the last day is the 15-minute depressurization, and we're going to speak in detail about this one on the last day, and how we're going to size the blow down valve and the pressure safety valve on the last day. The main problem for me, or the main issue for me now, we need to issue the PMDID, so other disciplines like piping and instrumentation need to work after us. So as a principle, we install the ESD here, there, and there, as we mentioned here. Let's see how actually this ESDs are being configured on the real PMDID. Here is the descender. Here is what we coming, the inlet line. Here is the first ESD. We have it as a boundary limit, as we mentioned before. Boundary limit, have an ESD at the boundary limit. Then the line is going to the three-phase separator, where we have the second ESD valve. So when we make a calculation for the blow down valve, we will start from here all the way back till we reach here, and all the inventory, the volume here, will be considered for this blow down valve. Is that all? No. Also, we will use the same for the pressure safety valve configuration. You got it, Muhammad? Naja?
Yeah, yes, doctor, yes.
Raja?
Yeah, yes.
I miss your voice. Raja?
Yes, I'm there.
Naja?
Yes, I got it.
Yes.
Anyone not following? Okay. Then going back here, then we have the ESD here upstream the unit, then we have another ESD downstream the gas line, and we have another ESD here downstream of the condensate line, then we have another ESD here for the water line. I have a problem. Naja, I have a problem, please. This one, we have this equipment, we have a ESD in the upstream, then we have a 3 ESDs at the 3 outlets. We have an ESD at the gas, we have an ESD at the water, we have an ESD at the condensate side. The question is why? This is for you, Naja. Okay, Naja is not here. This is for you, Muhammad.
Yes, doctor.
Why we have a 4 ESDs here? 1 here and 3 on the outstream.
Because this one, each one will be just like the first sectionalization part for each system, because after separator we have 3 streams which will be followed by, for example, another processing or another equipment.
Totally right. The question is, if we have like a 4 stream here, should we install a ESD valve on it? Hamad, the question for you, if we have a 4 stream from
Yes.
this separator, should we
Yes.
install a ESD for this one also?
Yes.
Totally right. Why yes? Because we need to isolate this equipment to make sure that we can size this blow down valve. Please focus with me. This blow down valve is a disaster. Why? Without identifying the inventory and saying this vessel volume is X, and this piping have a liquid, a gas is X, have a water X, have a condensate X, and have a feed stream X, we will not be able to size this blow down valve. That's why we need to identify this volume, this section. On the other hand, we need also to identify the pressure safety valve. The pressure safety valve, the blow down valve, the depressurization, whatever equipment we are speaking here and there. This one, for me, the most important. You learn that we need to depressurize this inventory, this section, in a 15 minutes in case of blow down valve. In case of pressure safety valve, we don't look to the time, we look to the setting. Set at which number? Set at which number? You got my point? Raja. Raja.
Excuse me, doctor.
Yes.
Why we can depend only on PSV, for example, because it will work when there is a set point for the pressure and it will depressurize the vessel. So why we should have, in addition to the PSV, we have the blow down valve?
Let me assume that you have a fire here, external fire. What will happen? Tell me.
Sorry, where I can see? Can you just move
Here,
your
here.
mouse? Yeah.
It is a fire, external fire.
Okay. Yes, yeah.
What will happen in your plant?
Pressure will increase.
Maybe the temperature will be increased and the pressure as well for inside if it is affected by or so close to the separator.
Okay, what else?
Maybe there is an alarm or a fire detector which will work.
No, fire is a protect what's called mitigation barriers, not a protective barriers. Fire detector is a mitigation, which is reduce the consequence, not preventing it. The question for you, Naja, what we have if we have external fire, what it will cost us? What is the problem if we have a external fire?
External fire, I think pressure only, because based on the temperature, the pressure will increase, and then
Why?
why? Because it will expand the fluid. If it is hydrocarbon fluid or whatever,
Why
it will expand. The property of the fluid, it will property of the fluid because
No. Consider me a basic technician. I don't understand it. Focus with me. Here is a fire, and I don't know anything about expansion or not know anything about what you say, entropy or enthalpy. Simply,
okay.
here we have a fire. Here we have a metal sheets, which is fabricating the separator, right?
Okay.
Hamad, you following?
Yes, yes, doctor.
Okay. Here is the sheet, metal sheets. It will, as a basic, as a normal, if you go to the kitchen, it will, if we have a pan and this pan on the oven and you fire it, it will absorb heat.
Yeah.
As it absorbs heat, we have two fluids here. We have two problems here. Let me put it here like this one. We have some gases there.
Yeah.
Sorry. We have gases here. We have a liquid here.
Yes.
Gases will not absorb heat because of what, Muhammad? Because of the expansion or the specific heat of the gases is very low, which means that it cannot absorb heat. Okay, I don't get it. Who will absorb the heat? The liquid will absorb heat. Liquids will start to take the heat from the metal sheet, the metal sheets,
Okay.
and start to boil off, increasing the generating more gases, which is squeezing the gas and making a lot of pressure. The question is, if this gas is still there, if this gas is still there and we didn't have a blow down valve, your question, Muhammad, from the beginning, if we didn't have a blow down valve, that means these gases will reach the 1360 psig, which is the setting for the pressure safety valve, very, very fast. What else will happen? This pressure safety valve will release the gases, then it closes again. But the fire is still running, and there is fire not burned off, not stopped. It is still running, and heat is just still passing to the metal sheets, which passing the heat by default to the liquid, and start to boil a lot of gases also. Start to boil a lot of gases also, generate a lot of gases. These gases will pressurize till it reaches the 1360. This pressure safety valve spring will open until releasing all the 1360 psig, then it will close again. Then heat is still running, it generates a lot of heat passing to the metal sheet, passing to the liquid, generate another gas, then make the spring of the pressure safety valve squeeze it to open the pressure safety valve. That means if we didn't have a blow down valve, this pressure safety valve will have to open and close many times. Open and close many times to release the generated gas by the boil of liquids. You got my point?
Yeah.
On the other hand, if we have a blow down valve here and we have a fire detection system, it will detect there's a fire. This blow down valve automatically from the fire and the gas panel, which is automatic and separated from the operator intervention. Operator don't have any permission to stop or to start this fire panels from working. Once the fire detection detects there is a fire, it will automatically send the signal to the control, and control will automatically open this blow down valve, which is a typical blow down valve or typical ball valve with a motor. It will take a signal to please open this pass. Once this line is open, all the gases will go to the flare, and the pressure safety valve is still not open. Okay? Once the fire is continuous running, the same case as we before. Fire is still running, passing the heat to the metal sheets, making some heat to the liquid, and the liquid will boil off some gases, will release some gases. The gases will not pressurize because there is an open path for it to the flare, and we will keep going this way. Fire, we have fire on the top, fire, external fire, passing the heat to the metal will absorb heat and give the heat to the liquid will boil off some gases will, once it's generated, will go to the flare through the blow down way, through this way, as you see from my mouse. You got it, Muhammad?
Yes, thank you, Doctor. Yeah.
Let me continue. On the other hand, if this is the case and the fire is continue and the liquid is boiling off till it is finished, when the liquid is finished, this tank will collapse, this separator will collapse. So that's why we are firefighting back the fire, to prevent this separator from collapse after fires. That's for the liquid. On the other hand, this blow down valve will release all the gases and will not prevent and will not ask for the assistance from the pressure safety valve to open. But some pessimistic, some non-happy man will ask me, what happens if we have a fire and we have a power cut? Power cut means there is no instrument air, and no instrument air, that there is no signal going to this blow down valve, and that means there's no way for these gases to go to the flare. That's why we install the pressure safety valve. That's why we install the pressure safety valve. As you know, as everyone know, a pressure safety valve is a mechanical device, not depending on any signals. Once the pressure is big enough to squeeze the spring, it will squeeze the spring and go out to the flare without looking to anything behind it. You got me?
Perfect.
Yes, doctor. Thank you very much. Yeah, it's clear. Just a question as well. How can we identify the blew down valve? Just like, and if it is has the same arrangement or configuration, just like the shutdown valve.
Let me say it. Did you see the HISE's B&ID file which I sent it to you?
Yes.
In this file you will have a typical arrangement for the ESD valve, which is coming. Let me
Yes.
for the ESD valve. This is the
Thank you.
This is the instrumentation input to the B&ID. Take care, everyone. When I ask for ESD valve here, my part as a process engineer, please, I need the ESD valve here. All this configuration, all this interlocks is coming from the instrumentation engineer. What are we have here? This one is for the low, for the high. Low means this valve is closed, high means thus is open. This is the position for the valve. This is closed, this open. What is this? This is to identify to anyone who reads this B&ID that it is solenoid, S for solenoid, and this solenoid is responsible for giving air to this flow, this ESD valve, and this ESD valve is connecting by interlock called interlock number 1 for ESD system, which will be shown on the cause and the effect. We are going to speak about the cause and the effect maybe today or tomorrow or the next day, depending on the time. That is the configuration, Muhammad, for a typical ESD. If we see this ESD, let's go in ESD, here another one, it will have the same configuration. Let's go for the blow down valve. Here is the positioners also, and here is the solenoid, and here is the trip. So it will have the same configuration, Muhammad. You got it?
Yeah. Okay, doctor. Thank you very much. But the shutdown valve for sectionalization purposes, it will be just like in the upstream, downstream of each equipment, right?
Depend on how much gases you have in your plant. Let me clarify what you said, Muhammad, because it is a good one.
Thank you.
Saja, focus with me, please. In this module, I decided as a process engineer, I will put ESD valve here. Follow my mouse, please. I install ESD valve here, install another ESD valve here, another one here, another one here. And I calculate this inventory, and based on that, I size the blow down valve for this one. I make a calculation for this blow down valve to make sure that all these gases inside this three-phase separator will be depressurized to. Focus with these two numbers which I will write now. To be less than 7 bar G in 15 minutes, or half of the design pressure. Let me share the white page to illustrate it in more. If we have a separator here, if we have a blue down valve here, this one should be responsible for venting this section in 15 minutes to reach 7 bar G or half the design pressure of the vessel. Naja, I bring this one from API 521. API 521. The question is, why 5 API 521 use design pressure, or why he specifically say 7 bar G? Half design pressure mean if this one is designed to be 11440 psig, I need to depressurize from 11440 to almost 700 psi in 15 minutes. Or from 11440 to almost 100 psi, which is equivalent to 7 bar, in the same 15 minutes. Both are valid. Why 15 minutes? And why 7 bar? And why the design pressure is half? I will leave it till the last day on the course. I will ask you to search for it. Let me write it in a Word document, so I send it to you after this one. Why in API to be 15 minutes for blue down valve? First question, why to reach design 0.5 design pressure, and why to reach 7 bar G inside the vessel. That's what we have, that we are going to discuss. Okay, Naja,
Okay.
Muhammad, and Raja,
Yeah.
we will take 20 minutes break till I install the HISES on Naja laptop. If you are interested, I can share the team viewer, which I do on Naja website, Naja laptop, to make sure that everyone is following. If you want to enjoy your 20-minute break, I will send the link for the recorded lectures. We have all this will be recorded. Okay?
Okay.
Okay.
Naja, can you send me
I will send you team viewer. I will send you.
Okay.
Oh.
Can you open your team viewer, because you are not opening it? Why? What is the stages of the BNID and how we can make the BNID for our clients, our views, and how we can review the BNID. The purpose or goal is to make an understanding of the BNID which we have. Piping and instrumentation diagram. Here is the jokey part. The jokey part is that piping and instrumentation diagram mean that there is no process. It is not our responsibility as a process engineer. Piping and instrumentation diagram is from the piping guys and the instrumentation guys, and the accountability to the process person. It is different from what you can hear from other courses. Why I'm saying that? Because simply the process people make the process flow diagram, and in ancient time or in previous time the process engineer will simply put in the process flow diagram, and instrumentation and piping guys are responsible for developing the BNID. But due to the misunderstanding of the piping and the instrumentation peoples, that's the accountability for the piping and the instrumentation diagram is coming under the process engineer. Is that important for us? Just a little bit of history. The most important for us is any BNID have this auxiliaries. Title block, which is be on the right, notes be on the right at the top, title block at the right on the bottom, upper baseline for the tower and visit, bottom baseline for the pumps and compressor, air cooler above upper baseline if possible. We make it on the higher part of the BNID. Exchanger at appropriate place according to your process. Line up of connection, left drawing or right higher or elevation. Any lines coming on your BNID just need to come from the left to the right. From the left to the right, not from the right to the left. Any line errors should be from the left to the right, until there is only 5 or 3 special things for this rule to be provoking or violating. Main process line thick, and take care of this. Thick lines, this means to be pulled lines. Utility and other process lines to be set. What we are showing on the BNID: equipment, piping, instrumentation, electrical insulation on client request. Take care about this because Aramco asks for insulation every time we are working with them. Tracing and jacketing. Types of BNID: legend BNID, process BNID, utility BNID, utility distribution BNID, interconnecting BNID. What's the meaning of interconnecting BNID? Hello, interconnecting BNID. Anyone know about it? Exactly. Interconnecting BNID is very, very important between two units. If we have one unit have a BNID and another unit have another BNID, and there is like a bunch of piping, a lot of piping between this phase 1 and phase 2, and there is a lot of isolation valve on this piping, simply you have to make this interconnecting BNID. It is very, very critical and important in the isolation of this equipment. Tie-in BNIDs, which is important for the piping guys, because tie-in BNIDs would show to the piping guys the location where they have to connect the pipe. And believe me when I said, in a small project like 100 or let's say 500 tie-in, you have at least from 10 to 15% tie points is not right. That's why we are making a tie-in BNIDs if a project is more than 500 tie-ins and higher. Demolition BNID, not all people ask about this one. Demolition BNID, which is how we can decommission and remove this equipment to scrap and sell it to the scrap people. Auxiliary and vendor BNID. Auxiliary, which is like the utility, under the utility, and vendor BNID, which is we received from the vendor, and how we can integrate it on our BNID. Take care, because every BNID, every vendor coming from different countries, they're coming from different principles about different understanding about the BNID. So, for example, if you work with Atlas Copco for the instrument air, or you work with nitrogen air leak for instrument air, let's say the same thing in the same equipment, air leak for the instrument air and Atlas Copco. Air leak is European one, they follow the British standard. Atlas Copco is now following the American standard, which will affect your BNID by 1. The pressure safety valve calculations and numbering and coefficients used for calculating there and here. In American, they have pressure safety valve coefficients for the equation in sizing the pressure safety valve is higher than that used in European. The line sizing, line color coding, the isolation philosophy, the venting philosophy, all of this different from Europe to America. Why? Because of the standard they are making. What you have in British is at least double block on the plate is the most common. In Europe, they depend on BB way, which is single valve under isolation, or spectacle or removable spool, depend on the equipment and itself. So take care when you're making this vendor BNID. We will see one of them. What is this? This is a legend. All the companies have their own legend, which is coming from the ISO standard or IEC standard. Both of these countries, all these companies coming from IEC is the most common, and some of them, if you are a European, taking from the ISO. This is a legend coming from many parts. We will go in detail about this. Use a type of BNID. It is a process BNID where you're showing the equipment as we said, we'll see in the separator. We see the process BNID and the control about it. Here is the utility distribution BNID. How the instrument air is moving all over the plant. Going to this unit, going to this unit, this unit, this unit, this unit. If it is instrument air or steam distribution, or it is hot oil, we have something to send and something to return. Interconnecting piping, which show the main pipelines connecting the major problems, major units, and how it is moving from this unit to another unit, and how the critical valves for the isolation. Tie-in BNIDs is used for just want to determine the location of the tie-in. Here is one. Here's the second one. Here's the third one. Why it is different? Type in BNIDs, the purpose of it for the piping keyboard, to make sure that they are not missing the correct position of the tie-in. Auxiliary BNIDs, the same as the utility, but you can use it for the boilers, for the hot oil, for the instrumentation, or if any of the cooling system supporting our process minutes. B&ID milestones. What we should know about this. This code or this numbering is depend on ABB or Bechtel. Both are following the same. Code CON for conceptual design, IFS for screening, for internal screening or internal review. This means if we are working in a bigger company and there is a multi-discipline of process, if I am working in a project and my partner working for another project, simply when I generate my B&ID, I give it to him. Please review this one. That's been done for PP on international scale. When BP have a project here in Egypt, they sending the B&ID after receiving from the client, from the engineering firm, to another BP office in Australia, Europe, West Asia for review. After approval from the client, issued for approval, we give it to the client. Please, we need your approval. Then basic engineering complete, then approval for design, then approval for detailed engineering, where we have the HAZOP comments. Then after this one, all the engineering or all the B&ID phase is finished. What is this? Once we have the approval after the HAZOP and we implement the HAZOP recommendation, we are going giving this B&ID to the piping engineers. Please generate the isometrics, or in another mode make the 3D model, and from the 3D model make the isometrics. Then please, we need construction, approval for the construction, and we need after the construction and all the modification on the site, we make the as-built to the clients. As-built is coming from any modification happen inside the plant. Any modification happen inside the plant. This is the milestone for the B&ID. There is a lot of work. The most important for B is this one. The issue for construction or issue for design developed phase. Basic engineering start with the issue for the B&ID. In this phase, the B&ID are developed up to approval for design state or issues. This is the most important part or most important stage in your B&ID life. To get the approval from the clients to enter the HAZOP, then you get the recommendation from the HAZOP, you close it, and your B&ID will be semi-final. You can give it to the piping guys to generate the isometrics, you can give it to the construction guys to start working. Whatever you want to do, you can do it with the B&ID after this stage. Then you have to make the as-built if you want it. The as-built drawing, if it is requested by the client or it is part of your job. The construction people make a lot of modification during the construction. That's why you need to make sure that what you have as a B&ID is equal to what is available there on the site. Okay. Here's some checklist for the revisions of the BNID. What I am interested in is line number, which we will learn today. This one is the most important for me. Issued for design. Tracing or jacketing, I will need it. Elevation of equipment. Or relief valve with sizes. Control valve with sizes. Instrumentation with numbers. Flow instrumentation types and size. Once we have all this finished, we are ready to go to the HAZOP for the engineer. Once we have the HAZOP here at the end, then we can go for the construction site. Okay. There's this 12 stages to develop your P&ID. Which one was the first day, which is the basis of design? What we are want or requested as an engineering firm to do. Then we generate the process flow diagram, which way we can achieve the objective of the project. Which way we can achieve the objective of the project. There is turbo expander or mechanical refrigerations or GT valve. All these three are typical, or how I can say it, can achieve the cooling of the gas. Which one your client need? Once you define the major BFD and you got your client approval, you'll go for the equipment selections. Then you have to define the mechanical design diagram. Do you remember? The mechanical design diagram, the maximum allowable working pressure for each equipment. Then you have to make the mechanical design diagram, which is the design pressure. Then making the piping between the equipment. Then if any of the piping need tracing or insulation, then you determine the piping specification, which rating we are speaking about, which size we are speaking about. If we have any special pipe items, then we have instrumentation, then the sample connection, then the safeguards, which is the pressure safety valves and the cool down valve, then the notes. We'll go to tackle each one by one. Let me make it this one bigger. Here is the development from BNID from the scratch to issued for design. This is the 12 stage which we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The basis of design, making the BFD, BNID, show all the spares and philosophies, making the MMD, mechanical design specification, and keep going. Let's jump to the basis of design. What we need from the basis of design when we're generating the BNID. For me, this is the most important one. Code and specs from the client. Code and specs from the client. That's all? No. Legend and symbols. Which symbols we are going to put on the BNID? I'm speaking now from a drafting point of view. Number of drawing. Title block. What we are going to say. What we're going to show on the BNID. Let me show this one. Heavy software. You see my AutoCAD screen? Anyone see my AutoCAD screen? Okay. That's on the right here is the title block. What we are going to do. Here is the scale. Here is the size of the printing. Here is the orientations. Here is the designation, the project name, the client name, the orientation as required by Total. Here is the addresses and all such things. Here is the B&ID issuings. What we have here, number of revisions and the date of revisions and who write each one. That's a typical process flow diagram or a typical B&ID have the same. Let me close this one and open what we need from a company like Total if we're going to work with them. Let's open the Total specs here. The last one I sent it to you on the WhatsApp. Did you see it? Hello guys. The last one I sent it on WhatsApp. Yes, thank you. Here we are. Let me share it. That's what we received actually from Total. Design Standard Engineering. As a company called Total, I will not accept any engineering drawing from your side until it's coming on my format. What do you mean? For layers, for lines, do you see all this one? Do you see my screen now or no? No? Okay. You see? Here is, please, primary process line. I will receive it to you in AutoCAD with a blue color. From the drawing it must be dark blue, 170. Piping man. Continuous pipeline, a continuous line not dotted, blue 5 from the print out color which you extracted from the AutoCAD. You got my point now? For example, air link. If you want to make the air link for the control valve, you have to use this line which is coming from the dark gray number 8 from the color coding for AutoCAD. All this one. Valves have to be on this. I don't know which color is this, but I can use it from Cayenne 4. I don't know which number is this. And keep going. That's something I got from my client, which is Total in this case, at the beginning of the project. Then, please, for the line types, continuous for primary process, future line primary process, air link, capability pipe for link for filling system, hydraulic connection if we have a hydraulic oil, electrical internal connection, mechanical linkage, and keep going down. For example, if you have air cooler, I will need equipment data box like this one. on the B and ID, which clarify if for anyone who has the B and ID on his hand to have the product, which product is inside this. For example, air cooler number tag 1000.1, then the type, is it end-use or direct air cooler, the design code for it, the design pressure, the working pressure, the inlet temperature, the outlet temperature, the duty, and the area for the bear and the fine. If I have a column, I will need all this info for the B and the ID. You got my point? Okay, furnace, exchangers, the same. Filters, compressors. Take care about this one because compressors and pumps we will go to make it. And here is the separators and the pumps. Storage tanks. Here is the symbols of the valves. Hydraulic and air symbols. Keep going down. Piping symbol if we have a line break. What's the meaning of line break? No, line rating changes here. Line break is there. What's the difference between line break and line rating? For line break, it is not a mechanical design change. It is like a branch from the pipeline. For line rating, that's what we are speaking about. It is a change on the rating of the pipe. Let me, before we go forward, I will need 5 minutes to speak about piping point of view for the piping, so we can make some. Where's my white screen? Sorry. I didn't say it. I will say it now. Give me 1 minute. I just try to find my white screen. Don't worry. Where is my white screen? Give me just 1 minute. Give me 1 minute. I will close all this. Okay. Everyone see my white page? Okay. For example, here is a separator. No, let me make it bigger. Here is a separator. Here is a pressure safety valve. Flare. Here's piping. Here. Another valve. Then we have break. Then to the again. Here's the gas line. Here's the end can. which we have rating. Let me see. Ah, what I did, focus with me, Muhammad. And here's a pull down valve. This is the rating from the ASME. Rating 150 can withstand 285 BSI. Rating 300 Muhammad can withstand 520. Rating 600, this window is for rating. 600 is like 1448, 1440. 900, 200, 2100 and 1600 or 1200, sorry, is for 4000 BSI. This is coming from the ASME. All of this at 80 C. And take care about this one. The question, Muhammad, for you. Muhammad, if this inlet feed is coming with 900, which is our case, BSI, we make the design pressure for this one equal 1440. This means we are going to use this one, right? Okay, this is the working pressure. And this is the design pressure. The question is, for all of you, what will be the rating for this pipeline and for this pipeline? Choose one of this. 150, 300, 600, 900, 1200. This pipeline, this means 600, and this one what's yes, 600. What's your opinion, Muhammad? Raja, I miss your voice. Okay, let's make it harder for you. This pressure safety valve setting is 1440. Raja, Raja. Raja. Where is Raja? Okay, he's not following. Muhammad, let's consider the pressure is increasing. If this pressure was 900, now it reach 1400. For example, your operator was not qualified, so the pressure increased here from 900 to 1400, and your operator didn't know why. The pressure was going to increase inside the vessel till it reached 1440. Then the pressure safety valve will open. Okay? This means this piping will see the same pressure of the vessel. That means this piping should be rated as the same as the vessel. You got my point? Let me clarify. Don't worry. I am following you. I just want to make sure that you are following me. On the other hand, if you make this one 900, make it 2000 rating. This 900 can withstand 220, right? From the table here. The question is there any chance that this vessel will reach this 220? The answer is no. Why? Because if the vessel reach 220, this means the vessel will explode or rupture before it reaches 2100, sorry, before it reaches 2100 psi. So making this higher rating will not affect my design. On the other side, it is more safe, but it will cost you a lot of money, because 900 rating is very, very expensive compared with 600. On the other hand, the 900 is no longer needed, as we are operating with 900 psi, and the maximum for us is 1440. After this, if this pressure safety valve is not working, this vessel will rupture. So instead of making the piping 900, 600 will be more than enough. 600 psi will be more than enough for this vessel. The question is for you, Muhammad, and Raja, and Naja also. The rating for this pipeline should be 600 or 900. It is connecting to the flare head. How many less? Give me a number. Choose one. You need here 150, the lowest on the rating. Why not giving it 600? What happened on this pressure safety valve? What's your opinion, Muhammad? Let me say it in another way. What happened in this pressure safety valve? It breaks the pressure between the 1440 till the 0. So if we make this piping here 120 1200 rating, which will withstand 4000, I don't have any problem. But it will cost you a lot of money, unnecessary money. Why unnecessary money? Because actually the pressure here is zero. How you can say this? It is breaking the pressure between 1440 and all the way till it reaches the flare stack, and all the gases go to the stack. What will happen? So what we are trying to do always is, if here is the stack and here is all the header till we reach our specific pressure safety valve, we try to make sure that the delta P here, differential pressure here, is less by increasing the diameter of this header. That's something we're going to learn at the last day. To allow the pressure here, Ya Muhammad, to not exceeding 50 psi maximum in the emergency case. Not exceeding 50 psi. Why? To avoid back pressure, which will affect the operation of this pressure safety valve. So we always, Ya Muhammad, go to this rating 150, because 50 psi maximum 150 is less than the 285 which is coming after the rating. So 285 downstream, the pressure safety valve is more than enough for the flare here and for the blow down. Let me open the BNID and see how it's really happened. Here is our BNID. Let's make this one. Let's delete all these marks. Sorry. Okay, have a look. This one supposed to work at operating pressure 900 psi at 50 Celsius, and the design for this separator is 1360 psi at 85 Celsius. And the pressure safety valve is, we have two 7002 A6002B, which is sized at 1360 psi. The rating is breaking at this point, as you can see from this slide. C3CA and C1CA. That's something I don't understand. C3 and C1. If I'm not understanding this, I should go to the legend. To see what's meaning of CA, C3 and C2. Here we are. This is the numbering of the legend of what we have. Line identification system. The first lines, pipe diameter in inch. Then the second 3 letters will be the fluid identification code. The C1AA, as we said, is the pipe material classes, rating and material. Then the H type of insulation if we have. Then the 1000 is the line serial number. Everyone follow me? Perfect. Let's go now. Here is the C1AA. What we have is a C. That's mean it is a carbon steel material. We have C1 is rating 150 and C2 or C3 rating 600. So if we go here back, it have carbon steel upstream and carbon steel downstream. C3 is rating 600, C1 is rating 150. You got my point, Muhammad? Ask. Yes, here is the line going to all the way to the cold vent header. Here we are. C1. Also C1. No, it shouldn't be higher. Why? Less. Why? Because the equipment is already have all the high pressure. So the piping between the equipment and the equipment itself should withstand this high pressure. Okay. When we are going to use the flare, when we want to get release of this high pressure, when we are releasing this high pressure, for example, let me put it here. Let me make it this. If the vessel here have a high pressure and we have a fireplace, we want to get rid of all this pressure. This means this pressure here will start to pressurize this piping here, this close, so pressure will go this side, going up until it reach the flange of the pressure safety valve. Then it enters the pressure safety valve, then it make a force on the spring of the pressure safety valve, and please open the way pressure safety valve. Then pressure safety valve will open the way for it to allow the gases which here which have a pressure 1360 to go all the way. Let's focus Muhammad. Here the flange open all the way, coming up, 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 moving till it reaches the flare stack. All this way is ended up by having a stack at the end, right? I don't know how it's made. It is a stack, but I don't know why it's making this. All this stack by the end will have open to atmosphere all the way till it reach here. For example, it is coming like this way. All this piping have a pressure which is almost maximum pressure. You can see on the flare header is 150 psi because of another constraints we are going to speak about it on the last day. Why we are seeing the 150 psi, Muhammad? Because of, and take care about this one. We should say this in the last week, but I will say it now. Here is the flare, the pressure safety valve. The velocity here should be 0.5 Mach, which is the velocity of the air, of the sound velocity. And the main header should have a velocity 0.7 Mach. So based on that, we cannot reach higher than 150 psi maximum on the flare header. What happens if in calculation we receive 170, for example, psi? We increase the diameter of this piping to allow the pressure to be 150 psi maximum, to keep this velocities the same numbers. Even if you're using flare analyzer software with this one, the program itself will not solve your model until these numbers is achieved. Based on that, we making this piping class C1, we make this piping class C3. You got it or not? Okay. Naja, how's your HYSYS? Okay. Let's share back to the here. Drain philosophy, startup philosophy, mechanical design, condition, side data should be mentioned on the BNID. No. Should be bring it from the basis of design. Yes. Domain philosophy, startup philosophy, and we have inlet for the plant, which can use it at the startup. Yes or no? And degree of automation we needed for this plant as a basis of the design. All this, yeah, Muhammad, is interesting in the basis of design. Yes. Degree of automation is very, very critical, but most of people leave it, don't understand what is degree of automation. or you want this plant to be fully automated, which means that everything will be controlled by the DCS and the operator intervention is minimum, or you want a certain degree, 50-50 for some Kuwait gas plants before. Anyhow, A, B, C, D, E, F, G, which is the symbol of the size, job number, area, code, sequence identifier, sheet numbering, demolifier and the identifier, demolition and identifier, how you demolish it, and the last is the revision number of the BNID. Is it important? No. For us, no, because the draft man take care about this one, but you have to guide him in case you work with a new draft man, like my case. Okay. Code for documentation, which we are following, depend on company to other. Process flow diagram 001, block flow diagram 002, utility symbols, BNIDs is from 5 to 9, depending on the amount of BNIDs and utilities. Steam utility BNID 12, steam to distribution 13, and any other things. Here is the title block. If you can see, ABP, AB Lemos, title of the document, the name of the document itself, the title of the document, the subtitle, the project location, and the revision number and the drawing number, which is coming from this one. Here is the drawing number, we take it and install it here, and the scale if we have a scale for the drawing. You following me, Muhammad, right? Naja, Naja. Raja. واضح ان مفيش غير انا وانت يا محمد. BFD is copied to a BNID format, divided in logical sections. بمعنى, which mean general guidelines. If you have 4 equipment is a maximum you can put in BFD. If you have a compressor or furnace, you can put 2 as maximum. If you have a exchanger, you can put 6 to 8 exchanger on one process flow diagram. Air coolers is 1 is good. Let's jump this exercise and go to practical one. Equipment. For each equipment, we have to make sure that if there is a spares or duplicate to be provided, are we going to have double bumps, one bump running and one standby? If we're going to have 2 heat exchangers, one running and one standby, or 2 compressor, one running and one standby. Detail hookup according to the client requirements, and all equipment such as silencer, ejector, flame arrestor, mixers, whatever, all this to be added, all the accessories to the equipment to be added on the BNID. If we have a vendor package like compressor package, in the initial phase we will go to make a black box. In the as-built, we will go to integrate the vendor drawing with our drawing. Mechanical design diagram, we speak about it last time, about the maximum allowable working, maximum design pressure for each equipment, for the rating for the pipes. Piping the same. complete piping with lines for startup, shutdown, regeneration of spec product, remaining system, instrumentation, all this to be shown on the BNID. Size lines, specific requirement to be indicated, and if we have any tracing on installation for the piping, we are going to present it on the BNID. Pipe specifications, as we said from the legend which we have from Total specs, or from the project we already delivered, the pipe legend and the pipe specs inside it for the pipe connecting between each equipment, and the rating for each pipe. And if there are any special piping items like steam traps, like double block check valve, like special valves, special hoses, special connections, and instrumentation to be shown on the BNID, like operation, specific operation, and the startup shutdowns for the instrumentation loop. Sample connection or analyzer for the lab people, laboratory people. We have to make sure that their lab connections or sample connection are integrated on the BNID, to not be missed during the construction, to not be missed by the quality people. Safeguarding is the pressure safety valves and the blow down valves to be installed on the separators, on the towers, on everywhere. And if there are any notes for what instruction for other disciplines, if you are speaking to other disciplines in your company as ABC, clarification or requirements, we can add a lot of wording to the client when he is reviewing, add a lot of requirements if we need something, special addition or requirements, special additional requirements for any the isolation or the drainage philosophies we need. That's the 12 part we are going to make for the BNID. This is a typical arrangement for heat exchangers. This is typical for heat exchangers also with a water side. Steam boiler. Yes, tell me. By who? Hook up. Hook up is simply the connections. This meaning by hook up, the connection between the vessels and the instrumentation. There's a drawing coming from the instrumentation department named hookup drawing. It is the connection between the piping people and the instrumentation people. Let me clarify it on the white page for you. You see my white page? If here is the piping, the pipeline. This is the pipeline, and here is one of the pressure transmitter from the instrumentation to be installed to this piping. Pressure transmitter to be installed, should be on the flange, right? And it should have a valve to be isolated. Then we have another flange. Then we have the pressure gauge or pressure transmitter, depend on what we have. The hookup drawing is showing the boundary limit or the limits between. Let me choose another color. Between the piping people and the E&I engineers. Why? The piping will take this valve in account when they're making the isometrics. Isometrics for fabrication. So they will make this pipeline, then they make the connection here, the flange here, and make another flange here, then install the valve, then they make another flange. So the instrumentation engineer, the commissioning instrumentation engineer, will bring his pressure transmitter and coming to this flange and start to install his pressure transmitter. This is basically the hookup drawing, showing the connection between the piping and the instrumentation. Is it clear? Okay. Okay, typicals drawing. We share a lot of typical drawings last time. The most important for me, types of heat exchangers, how we are presenting it on the BNID. This is coming from TEMA classifications. TEMA classifications, different head, different tails, different body. You have to select one depending on which process you need, which fluids you are processing. Like, let's move this one. Okay, let's focus on this one. You see this, Muhammad, right? What is this? This is a typical level gauge configuration, which means that in any vessel, vertical or horizontal vessel, we have to make this configuration for the level glass, which means how we can do it. Let me draw on this. Look, here is the vessel and here is the 2-inch manual valves. The piping people will stop. Look, here is the vessel, here is the piping, here is the vessel, here is the piping. The vessel people will provide you with this. Let me zoom in. With this flange. Then the piping people will provide you with this valve, this piping, valve, reducer or enlarger. Then all this piping is coming to you till it is stop here, stopping here, here, here and here. This is inside the piping. Outside will be the instrumentation people. They're coming to install the level glass for you. This is the typical configurations between, or typical hookup configuration between the vessels. Here is the vessels, piping people, and instrumentation people. The question is why we are interested, deep interested in seeing this hookup drawing, because during construction you didn't know, a lot of people saying that they didn't know that was mine. The level glass is a piping support, it's a piping responsibility. Piping saying the level glass is instrumentation responsibility. This is actually what happened with me in Emirates. So the hookup drawing is allowing you to identify the boundary limits between each discipline. This is for a two-phase separator, a small vessel. If you go down, if you go down, this is a typical configuration for a pressure safety valve. Here is the process line. Should we have a pressure gauge, pressure indication on the top of the vessel, then we have a line, we have a valve, manual valve, which will be look open or look closed depending on what you need. Then we have a blade. Then we have the pressure safety valve configuration. Look, Muhammad. Then we have the configuration here for the piping brake. Then we have a enlarger before we have a reducer. Then the setting at how many bar G. Then we're going up to have the level look out, tag out, the another manual valve for isolation purposes. So in case I am operation and this pressure safety valve have a problem, I want to inspection, so I can isolate here, isolate there, and take it out to isolate, to maintain, to whatever I want, to calibrate whatever I want, and depend on the other pressure safety valve to operate. This is a typical for two pressure safety valve working in series, and the bypass also is here. Why we need the bypass in case of manual depressurization? You got my point, Muhammad? Naja, are you here? Naja? Ah, welcome back. How's your HISES? Okay, open it. Okay, perfect for me. That we have a typical configuration for the pressure safety valve. That's what we have for level glass. That we have for a control valve, on-off control valve. How it's work? We have the control valve in the middle. We have reducer before, enlarger after. Who is can you everyone make a mute, please? Naja, make it mute, Naja. Okay, thank you. Here is the control valve. Here is the enlarger and reducer. Here is the enlarger. What I am trying to do is to make you familiar with this configuration. Here is the process line. Then we have split. Then we have bypass with a manual valve. Then we have one globe valve before, one globe valve downstream. We have one vent here. Then we have the control valve. We have the reducer here. We have the enlarger there. To make sure that this is the typical configuration, please memorize it on your head. When we're going to the 3D, the 3-phase separator, we are going to use it. This one and all of the above. Okay. Utility connection. Here is a typical configuration for utility connection. If we have a steam, if we have who is in the lobby? Mark, are you always in the lobby or anyone else? People are waiting in the lobby. Waiting. 1, 2, 3, who is waiting? Mark, there's the people on the lobby, please. I don't know who is the lobby. Let me text Mark 1 minute. Okay. Let's go back to our BNID. Here is the typical utility connections. We have valve with a spectacle line, we have the bleed, we have the check valve, we have another valve at the boundary limit. Pressure indication hookup drawing. As we mentioned before, Muhammad, here is the incoming pipelines, here is the outcoming pipelines. What is the difference? The difference is nothing. The difference is nothing. Here is if we come, we have to pass to the valve first. If we're going out of the equipment, we have to pass to the pressure indication first. Okay. Pressure equipment versus interface with other discipline. Okay. Here is what we need from other disciplines. Here is what other disciplines want from us. The piping design. Piping studies. Piping plans, 3D model, isometries are based on the B&ID. Line schedule and the plot plan. Which mean is, let me finish all the interaction, then I come back. Okay. Here is the piping design. What we need from us is line schedule and the plot plan. So your first task will be to make a line list. A line list for the B&ID which you have. 1. To satisfy our piping engineers. A special piping item, valve types, special piping specification and look system are indicated on the B&ID. The piping engineers will need from us the lookout tag out for each valve so they can provide the valve with all its accessories. We don't want them to buy a valve without any locking accessories. Then we ask them, please, we need a lock here. Pipe stress. For pipe stress calculation, the line routes, not from us. A line schedule, 2-phase or 1-phase. This from the process beam, from the process team. All this, let's show it on the B&ID. Let's discuss this on the B&ID. Let's stop sharing here. Let's share the B&ID. Okay. Okay, instead of this, I will close it and open it again. It's easier for me. share it. Okay. Let's put ourselves on the shoes of the who is waiting on the lobby? On the shoes of the piping people. What the piping people will need from us? What the piping people need from us? First thing, they will need the name of the line. So here, this line will be 8-inch HG C3 CA N 1004. Don't understand what is all this. Let's go up a little bit. Here is the beginning of our plan. Let's go up a little bit more. Go to the legend. This is how we're going to name our plant. We're going to start with 1000 for the piping, and H is the for the insulation, and CAA for the. Here we are. Let me just pick a one. Let me pick one. For example, this means if we need C is a carbon steel. Do we have a low temperature carbon steel? No. We have any aluminium? No. We have any stainless steel? No. We have a duplex? No. The only we have is carbon steel. So this means if I'm going to name it, I will use this one, C. If we have another thing, another material, another specification, if our gas, for example, is going beyond -29 C, is yes, I will jump to the the low. Sorry. I will jump to the low temperature carbon steel LT, but this is not our case. That's not our case. Our case is all the gases, liquid, are in the ambient temperatures. We don't have any cooling effect. Then one, what is one? The rating. Most of our equipment, the basis of design, if you remember, saying that it is working from 250 to 900 BSIG. So the worst case is 900. 900 will be corresponding to the 600 rating. So C3 will be common for each pipeline. Corrosion allowance. Do we have H2S? Is there any corrosion allowance are requested by our corrosion expert? No. Yes. If no, we'll go stick with the C, which is 3 mm, which is the typical for sweet surfaces containing hydrocarbon. 3 mm is more than good. If there are any special needs for H2S presence, for example, we going to use the 6 mm. This is one of the cases when we have H2S, but this is not our case here, so we will stick with C. Now the most important for me is this surface fluid, process or utility, or it is a firefighting water or chemical injection or special surfaces. If it is process, we're going for A. we're going to A. Okay, here is this part. That's all? No, we still have this part, which is the H. H is coming from the insulation type. If it is heat insulation, if we have some temperature we need to keep it, we have to make heat insulation. If the weather is cold, we make a cold insulation. If there's no insulation, we will simply put in no insulation. If there's a personal protection need, we need a P. Coating and wrapping will what R. Okay, anyone following me? Then we have the 1000 as a number. Triple F is referring for the fluid identification letters. If we have instrument air, process air, instrument air, utility air. If we have a crude oil, CO. If we have open drain, DO. 4-point depression chemicals, salinity drains, closed drains, steam condensate. If we have a fuel gas, we will use GF and keep going all the way down. So let's start with the first BNID. Here we are. Yes, tell me. This is the default fighting between the piping and the process. There's no yes or no answer in this one, because if you work in Xitran, line number will give it by the piping people. If you work in what's this, ODE for example, or wood, a process, you are responsible to giving the line number to the piping people. It depends on which company. By the end of the day, line numbering is not that hard, as you can see now. You will see now. This is 1000, 1001, 1002, and keep counting all the ways. But depend on where you work, which company, and which environment you are working in. You got my point? Hello? Okay. Okay. So let's start. Here is the feed coming from the well. What we have, the first line here. First line is representing the first tie-in. So we have tie-in point or tie-in connection here. After the 6-inch valve, which is given by this company, our client will be Wasco company. Then we have this 6-inch. We're going to make it larger to be 10-inch. 10-inch hydrocarbon for HG, hydrocarbon gases. Then we have C3, which is rating 600, CA, which we have insulation normally, this C for carbon steel, and this A for the 3mm. Then we have the R, which is no insulation requested, wrapping because it is underground. If you see, above ground, underground, above ground. So underground, we will make a wrapping for the pipeline. Then we have the piping number is called B1001. 1001. Then we have, do you remember when we said that in any boundary limit we have the double block and the bleed? It is two manual valve with a blade or one valve with a spectacle, depend on the boundary limit. This valve, this pipeline will be 8-inch hydrocarbon gases C3CA N1002. Then we have this pipeline can go back bypassing all the plants by 1001, 1002, 1003 pipeline. This is still 10-inch. So, as per the client request, in case of the compressor failure, in case of this equipment is not running, we need to bypass it. Bypass it like doing what? Using the gas like here, coming all the way back to the manifold, existing Shara Boss manifold. This is one way. It's coming on the basis of design. What else coming on the basis of design? We need to use the nodal compression stations. Okay, let's enter. Once we enter, we have our biggest boundary limits, which is the ESD shutdown valve. Shutdown valve, we're going to take it starting with 4001, and pressure transmitter going to start with 3001. Take care about the numbers because we are going to use it. 4001, 3001, and here is the shutdown valve with all the configuration about it and even the bypass about it. Take care, we write a note number 5 on the bypass. So let's see what's note 5. Note 5 is called equalization line. I don't understand this. What is the meaning of equalization line? Anyone know? Anyone know what's the meaning of equalization line? Yeah, tell me. For me, as an operation, what happened if we didn't have this equalization line? Why? Totally right. You got this, Muhammad? Okay, I will repeat it again. Why we have equalization line here? Why we have equalization line here? Because on the startup, the pressure here at this section will be zero. On the pressure on this side will be the 900. So delta B between 900 and 0 will make the rotation of this valve is very hard. So it will a momentum on the valve body, and in sometimes it will break the valve. Okay, if we don't want to break the valve, what we should do, we should make the equalization line. Simply, if it is a pressure here is 900, we will open this two manual valve to starting to build up pressure at this section till we reach like 850. When we reach 850, we will give the signal to this shutdown valve to open, and it will open. So depend on the equalization line, and this is the most important part. This is what we meant when we say on the BNID we have to search for the startup accessories, startup method. This is coming when we asking how we're going to operate this, because the initial BNID should we have is the ESD valve, and we didn't have this equalization line. We added this equalization line when we are giving this BNID to our operation people, asking please write the operation manual. They coming back to us saying how we can write the operation manual if we cannot open the valve. You got my point, everyone? Here we go. No, for the ESD, maintenance of ESD can be done during plant shutdown, not during normal operation. This is always the rule. This is the rule always, but there's a lot of deviation depending on the client request. Yes, the black startup on another word. Yes, and so if there is a control valve and you have a damage on it, simply you will see when we go to the control valve in the separator. I will speak about it. Okay. Then we have this line till it reach the vessel. Let me remove all of this so it will be clear for you. Okay, this line 1002 is starting from here till it reach all the way till it go inside the descender. Look, because descender can be entered by a human, the typical configuration for this one is double block and bleed for the inlet, double block and bleed for the outlet. This is a typical configuration for it. Okay, let's move forward. Then we have the blow down valve, which is, as you can see, manual valve here, manual valve there. Then we have RO. Then we have the typical configuration for the blow down valve. You got my point? Hello? Okay. On the other hand, here is the flange. Here is the typical configuration for the pressure safety valve. With the two pressure safety valve at the same setting, and we have the bypass for the manual depressurization. That is the safeguarding here in 1 and 2. That is the isolation philosophy 1 and 2. Yes. Look close and look open. No, it is operation manual. Look Muhammad. The client request was that, please, we need sparing for the pressure safety valve. These units will be located on the western desert in Egypt, which is far by like 400 kilometers from the nearest town. So, what we need as a client and what was requesting from us as an engineering company, for every pressure safety valve, we need it. We have to have two in parallel, which means one is working and the other one is on a standby. One, look to my mouse. If I am, if I am the gas and go up, this way is closed. Look close. This way is closed. I will go to this way only, going to the pressure safety valve. So this pressure safety valve is on service, and this one is standby. So and so. This one, when it's open, the way is almost open for it till it reach to the flare header, and from the flare header to the flare stack. That's what we have. This is called sparing philosophy. On another word, if I have, just ignore this one, it does not exist. And we have single pressure safety valve with its own bypass, and we don't have all this branch on the other side, on the right side. Simply, if this pressure safety valve is open for any reason, this one should be removed and calibrated. To make this calibration, this means this unit will be shut down because there is no pressure safety valve installed on it, because it is on the calibration test now. On the other hand, when the client requires this, as ENI also almost all the time requires this one, to have one working and one standby. So in case you need this for maintenance or calibration for anything, this one will act as the pressure safety valve. So this A is duplicate to B, or this B is duplicate to A. Any one of them will do the job. Any one of them will do the job. Why we are putting two? To make sure that this equipment, in case of this pressure safety valve failure, this one will be there. In case of this one maintenance, this one will be here, not failure. This one, in case of maintenance or calibration, this one will be there. You just align this valve. You open this valve, look close, open it, you open this valve, and this pressure safety valve will be on surface. Yes, ask me. Anyone ask me? Sorry? Is this one? This one, right? Leave it to the last day. I will explain the blue down calculation and the RO selection. Don't worry. I will not leave you in the middle of the desert. How's your HYSES? Is it finished? Please tell me it's finished. Naja. What do you mean? Just press the window tab at the bottom. Say type HYSES, HYSYS, and you will have only one HYSES at the bottom, at the top. Yes, just use HYSES only. Press HYSES. Okay, just we will share your team viewer again, and I will do it. Yes, please. I will give you how I give you control. Show meeting, show devices. Tell me. You should ask me to share or what? What? Okay, share it. No, it is black, as you're making with me. It is coming, but I just joking with you. It's coming on the way. Yes, HYSYS, not IS. Take your time. It's not clear till the moment. It is not clear on my side. Just give it one minute to load on my side. Yes, this has been HYSES version 11. Press on it. No, you just close this tour video. Yes. Press new. Yes. Just put in your mind that it take a lot of time to come on my side. It is not a team viewer here. It is Teams. It's still on my side. It's still the mouse is not moving. Yes, or you simply can open the cases which I shared with you on WhatsApp now. Okay, that means it's working with you now. That's a good part for me. Okay. Yes. Or you simply open my bucket, or the case which I dropped to you. What should be easier. I didn't see your screen. It is yes. Aspen License Manager, Aspen Properties, Aspen Plus, Engineering Tools, and all of this. Yes. What about this? What do you want to understand this? Aspect Basic Engineering is helping for developing the P&ID. Aspect Engineering Tools is helping for the sizing tools. EDR for heat exchanger. Economic evaluation for the finance and peoples and how they making a lot of money. Configuration is how you're working with your environment. Aspen Plus is for petrochemicals. Aspen Properties for if you want to try anything new on your lab and you want to make what I can say, the reaction rate for a new catalyst, you can put there. Okay. No, Aspen Hysis. During my course, Aspen Hysis. Yes, Aspen Hysis, go down. Aspen Hysis. It is loading on my side, not coming to. Yes, thank you. This is the one. Yes, and on. You're welcome. And also on Aspen flare system, which is above this will help you for flaring system. I will make on the last day like 5-minute presentation about this one. Okay, can you just let me open my share back, please? Okay, thank you. Muhammad, welcome. Muhammad, you're the only one that didn't have Hysis till the moment. Okay. You downloaded from the same website, Get In Tech, right? Okay. Okay. After this one, after we finish today, you stay with me on TeamViewer, and I will help you to install it. Okay? You're welcome. Let's share the P&ID again and come back to our what we are doing. The good part here that we have the pressure safety valves and the sparing one. We have the double block and blade for the isolation equipment. We have a single valve for the drain philosophy. Single valve, yes, they ask for a single valve for the drain philosophy. That will be asking about it. Okay. The question, Muhammad. Here we have a pressure transmitter, the first one we met as a gas and coming all the way here. Then we have a pressure transmitter number 3001. Then we have a pressure transmitter 3002. This is the configuration between the piping and the instrumentation. This one gives you alarm high and low alarm. This one, pressure transmitter 3002, give you ESD signal for high and low. For me, I don't understand any word of this. Can you explain to me? Yes, go, please. Tell me. Any one of them. I just want to understand how. Yes, tell me. I don't get any word. This one? Which pressure transmitter you see? Yes. Okay. Yes. High and low. Okay. What else? Okay. Let me put it in this way. For you, Muhammad and Najah. One, we have something called basic process control. Two, we have something called safety and instrumentation system, which is both is the first part of the safeguard, which prevent this vessel from explode. Simply, how is this happening? Basic process control, ya Muhammad, is if this line from the basis of design coming from 250 psi till 900, if the pressure increase till it reach 1100 psi, we need to have some alarm saying that take care, the pressure is increasing. If we operating on 900, if it is going down to like 100 psi, we need some alarm to say to the operator, please take care, it is going down, it is 100 psi, please make something, for example. Okay, Muhammad, you following me? This is a very important part. On the other hand, if the operator fail to respond to these alarms, the designer, which is in this case we, assume that the operator didn't have control. So we take the control from the operator by making the fail safe position, which means we making another alarm, which is in this case high and low. High, for example, will be 3000. Low, for example, will be 5 psi, 50. This is the case when this transmitter will send a signal to the control room asking to activate the cause and effect, asking to activate the safeguard, which in this case is what happened? Sorry. Which in this case this ESD valve will close this shutdown valve. Based on what you decide that high will close this shutdown valve. Pressure alarm high will make a trip for the system and close the inlet for the system. Why you choose this action? Because 1300 is very close to the, where is it? I am searching for the, here. For the descender design data, which we put it on the BMID. The design pressure, Muhammad, is 1360 psi. After this, the pressure safety valve will open. So I don't want the pressure safety valve to open. I want it to fail safe and make the contaminated gas, all the condensate, all the water inside the vessel. That's why if the pressure reach 1300, this alarm will activate it, asking the trip from the DCS, and this will close the shutdown valve. This system is called safety instrumentation system. Okay, what else? Safety instrumentation system, this one, if the safety instrumentation system fail, in this case I will have the pressure safety valve as the last layer of protection, which I will have it. You got my point? Don't worry, last day we will serve the pressure safety valve design equations API 521 for the pressure safety valve, for the blue down valve, for the flare net. Don't worry, we will do it. But keep this question. But for just a quick answer for what you want, here is the design pressure, and we have almost 27 cases to work, 26 cases to work above design pressure, and we have 3 cases to work down the pressure safety valve setting. This is very clear in API 521. If you go 521 on the scenarios on section 3, you'll have it very, very clear. Anyhow, you're welcome. Yes, totally right. Okay. Okay. For me, I will be happy if we are in the class now. I will ask you to bring A3 page and draw this 3-phase separator by pencil. Hello? If we are in a class now, I will ask this all of you to bring A3 page, white page, and draw this three-phase separator by a pencil. Do you see this dashed line? I will even ask you to draw this dashed line, even the notes, even the logos. So this will be your homework. On a big A3 page, I will need you, all of you, Muhammad, you Naja, even Raja, who is not hearing us, who is recording this session. I will need you all to draw this one on A3 with the smallest detail. I will ask for the look close, look open. I will ask for the configuration, the piping break. I ask for the RO. I will ask for the position. I will ask for everything. You follow me, Muhammad? With a pencil. With a pencil. You know A3 page, A3 paper. You will bring 3 or 4 A3 pages. You will start to draw this one with your hand. Why? When you're going to write this, Muhammad, with your hand, just for example, you will draw this arrow and you will start to asking why this wording is not inside here. Should be this wording to be inside here, yes or no? This is the most effective way you can comment on. If you work in ABC contractor, you can comment on your drafter. If you're in the owner, you will ask why. The comments will be very effective when you are reviewing a B&ID. Then the skid, what is this dashed line? I don't understand it. Then I follow it. Then I follow it. Then I follow it. It is X02. Package limit. What's X02? Three-phase separator package. That means this valve will be on a skid. This piping will be off a skid. You got my point, Muhammad? Then this pipeline will have all these valves. When you draw by your hand a control valve and you make this inside, pull it by your hand, you will always remember the valve shape. The look close, look close, look close, look close tags. The full close, the fail close. What's the fail close? You are coming to ask me what is the meaning of fail close next time. What does it mean by failing close, Muhammad? Totally right. Yes. Tell me. Let me ask for this. This one fell close, right? Take care, Muhammad. Look, Muhammad, focus on the screen, Muhammad. This one fell close. This one fell close. For the ESD, it's always fill close, right? Right? For the ESD, it is always fail close. The question is, for the flow control, is it fail close always? Depend on what? Depend on what? Totally right. Naja? Yes, Muhammad, tell me. Tell me. Totally right. Bravo, Muhammad. Naja. 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 I will ask you, when you're drawing this one, please, 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 make sure there is a pass for the gas to flare. That's your task. Make sure that gas to the flare. The position of the control valves. You, Muhammad, I will need to make sure that you have a liquid pass to the surge drum. So make sure of the control valve position in case of instrument air failure, power failure, whatever failures. Now you will have two different bases of design. This will reflect two different P&ID. What we have here in the P&ID, we didn't have any bus for the gas, we didn't have any bus for the liquid in case of emergency. We have a different way. I will not say it now. When you draw this one, in every single detail, ya Muhammad, every single detail, Naja, even the flange here, even the flange shape, this one, I will ask for it. Okay? The last thing for me today is, let me just close this. No, I don't. Let me share the Aspen Heises for you. Everyone see my white screen on Heises? Is it clear now? What happened? Why is not showing? Is it clear now? Hello? Okay, Naja. Naja? Can you please? Yes, please. Can you share your screen and give me control? I will work from your side. Yes, 111. Just go to 111 and press it. What are you doing? Yes. Yes, the first one. And go open recent. Just use the 111. Recent on the right. Yes. Well, you have a lot of things. Okay. Hamad, you following me, right? Okay, this was the case we make it before. I have a problem, Muhammad. The problem is I don't know the pipeline here. What is the dimension of the pipeline? This is the length. This is the length. Sorry? Yes, the length, where I get the length? Where I get the length? I get the length from the layout. Can you share the layout, please, Naja? The one I sent it to you on the WhatsApp. No, I sent it before the starting of this session. Okay, not a big issue. I will open it after I finish this, Muhammad. Just focus with me. What I have here is Can you give me control back, Naja? Okay. Okay, perfect. Thank you. The problem is, Muhammad, I get from the piping people who bought the layout, the preliminary layout. They telling me, Said, take care. The feed from the well to the separator will be almost 300 meter piping. 300 meter piping. So which size of piping diameter we should select? Should we go for 2 inch, 3 inch till 24 inch, or which size? So basically what we need to do here is to make a hydraulic calculation. What HYSYS is providing for us? Hydraulic tool called pipe segment. This pipe segment, I want the feed from the gas well to enter this pipe segment, then the outlet to go to the three-phase separator. I can disconnect and connect, but I don't love this way. What I love to do is make another stream here and another stream out, then pressing control, connect this one with this one and connect this one with this one. Now I don't know what is one. I will define it from the other stream called from the gas well. I will take everything, temperature, pressure, composition, and everything. So it will be identified. Close it. Let's go to the pipe segment and try many different piping diameters. Look from the worksheet, Muhammad. This one is coming with temperature, ambient, and the pressure almost 16 bar G. 16 bar G, which is 250 psi. Remember, Muhammad, 250 psi is the minimum for the design of bases which we have. Let's back here. He required an energy stream. Let's name it energy stream for it. Let's say Q line, for example, any name. Now he have his energy stream, but till the moment we didn't make the rating. So rating, sizing, then a bend segment. What we take from the piping engineer, that it is a pipe, total length is, for example, 300. Is this any elevation change? Is it going up and down? No, it is a straight run. Is it audio diameter? Double click. Let's choose the standard 40 and the nominal diameter. Let's see which diameter we need, Muhammad, and then analyze the selection of the diameter. For example, let's start with 4-inch. Close it. Then he says that heat transfer information is under specification. Let's go for the heat transfer. Estimate heat transfer. Ambient temperature is almost 35. He say what, Muhammad? Muhammad, what? Not solved. Let's go back for the double click. For the diameter, double click and make it bigger. 100. Let's take 6 inch. 6 inches. Okay. Muhammad, you follow? Okay, 6 inches okay for him. Is that enough for the hydraulic? No. Let's go for the flow assurance. What we are afraid of the erosion velocity. Let's do a calculation, erosion velocity calculations. We have a big problem here. Here is our fluid velocity. It is interact with the erosional velocity, ya Muhammad. This means this fluid will go inside the piping with a very fast velocity, very close to the erosional velocity. This means it will making like a sandblasting inside the piping. So this piping need to be bigger to reduce the velocity of the fluid inside the piping, and to make sure that this piping will live almost the 20 years which is supposed to be the lifetime for the piping. So let's go back and try. Yes. There's interaction between them at the end. Okay, when we go to the 8-inch, this grab will be higher, right? Is it logic? But we will not stick with the 8-inch. Do you know why? Because we need to work between 0.3 to 0.7 of the erosional velocity. So we have to be away from the erosional velocity. So let's go for a rating. Let's go for another piping in a state of 6-inch. Let's go for 200-inch, which is the 8. Not solve it. Why? Hello? Yes, it stopped. I don't know why it stopped. It's frozen. This photo is not accepted. This control. Naja. Naja. Hey. Waiting for approval from Naja site. I don't understand. Naja is disappeared. Okay. Anyhow, Muhammad, that's what we are trying to do. Is that what? Totally right. Totally right. If without the erosion we were not able to make a good hydraulic. Do you see what I have on the screen? It is a typical 3D model for a oil terminal. I just did it. This terminal is the same principle. From here I get the piping. As you can see, I can select which piping I want. And from here I can get the isometrics for the piping, and from the isometrics I can put it on the ICES to make the exact hydraulic calculations. You got my point? let me share what was done on the old days. Old days we didn't have these HYSES. We didn't have any of such wonderful softwares. What we was doing is we depend on the D&ID, on the Excel sheets. Let me open one of my favorite Excel sheets. Just 1 minute. Okay, and everything. Let me share this with you, Muhammad. Do you see this, Muhammad? Okay. This is the old Excel sheet for Wally version, which you have it in your WhatsApp and on your Google Drive. Let me check. Come on. Where is I'm just waiting for Naja because he was out and he was on the lobby. Then he was out. Don't worry. After this, you will enjoy the same. You see this line, liquid line, hydraulic. Liquid pressure drop and particles. This is what we used to do. We need to calculate the pressure drop in a piping, in equipment, in a control valve. Any one of them, Muhammad, you have to select, for example, piping from well to separator. You following me, Muhammad, right? Outlet pressure and temperature, mass flow rate. You have to bring it from the HYSES, or you have to know the flow. Let's say it is 10,000, for example. Design margin is 10%. Velocity for the gas or the liquid, like noted 700. 50. Naja, are you here? No problem. When we HYSES fail us, we go to the normal Excel sheet, the old fashioned. Are you yes, you see my Excel sheets? It is already shared with you. The link I shared with you. It is a calculation 2014 with Wally Parson. You will have for the pressure safety valve sizing, the three-phase separator sizing, the line hydraulic. It is we're making the same line we did it with your HYSES. From the well to the separator, Then we have the inlet pressure, the temperature, the mass flow rate, the design margin, the density at working temperature, which is 100 Fahrenheit, and the density at the 60 Fahrenheit, which will be a little bit higher. Viscosity of the gas, let's make it 0.5 centibars. Okay, let's put it 2 centibars because he is confusing. Then we have the ID of the pipeline. Let's go for 8-inch. Nominal size, let's choose the same 8. Piping schedule, let's go for the 40. Then it will give you the velocity, standard volumetric flow rate in barrel and in gallon, and the ID, the area. The fluid velocity is 0.18. Take care, it is transaction flow. You have a lot of turbulence inside because you have a high Reynolds number, which is higher than the normal flow, which is or the laminar flow. The delta B pressure drop will be almost 0.00 nothing. Let me make it bigger for you. 6-inch nominal pipe diameter. The schedule 40. Just want to make it bigger for the volume and the diameter to see the the 8-inch. No, let's go for 4-inch to see the actual pressure drop. Here is the actual pressure drop for 4-inch, which is 0.03 psi for each 30 meter or 100 Fahrenheit. If we use 8, almost the delta B would be nothing for a small quantity like 10,000. If we put 1 million, yes, the delta B will be 4 psi's for every 100 feet. This is the old way. This is the old way for the piping, or even for the equipment, or even for the control valves. To calculate the delta B, the cross of the equipment, the valves, the piping. We have now the old way, we have now the new way for the HYSYS, for the pressure drop calculations for each one. Is it clear for everyone? For the, I don't get it. For the pipe you ask, or for the pump? Yes. Okay. Pressure drop have a limitation. Have some limitations. Let me share this one and do it. Everyone can see my white screen, right? Hello? Okay. If this is a pump section, hammam discharge. Typically, the only constraint for any pipeline is the original velocity, which is can be get from API 14E, which is a rule of thumb 10 meter per second for gases and 4 meter per second for liquid. On other hand, the pump specification for the suction, if you work with the total, they ask you to have a velocity here 8.2 meter per second for liquids as a maximum, and for discharge you can reach till 5 meter per second. If you work with BP, they accepting the 2, and here they accepting 4. If you work with Shell, here accepting 2, here accepting 3.8. This is the limitation. The question is, if we have the velocity like this one, and during the calculation we found that we are above the limit, that means we have to increase the diameter of the pipeline to reduce the velocity, to reduce the delta P. You got it? Muhammad, Naja, anyone following me? No problem. You're welcome. Delta B have a limitation. For Aramco, 5 psi per 100 feet as your limitation. Delta B have a limitation for each company of them, of this Total, PB, Shell. All of them have a limitation for the delta B and a limitation for the velocity. You have to respect here and there by using the proper pipe diameter. Without respecting these limitations, simply your design will be rejected, or on another word, if you work close to the original velocity, after 1 year you will find pipeline have a lot of pinholes. Or simply, if you didn't respect the delta B limitation, your pump lifetime will be shorted by 30%, because it have a lot to make a lot of power, a lot of pressure to overcome the delta B. This means you are always pushing to the maximum for your pump. That will make you reduce your lifetime by 30%. You got it? Leave it to the next time, because next time we will make a sizing for the compressor and for the pump. We will be limited by the boundary limit of our plant and how much pressure we need to deliver out of our plant. Welcome. Any question, Naja? For the hydraulic, not a big issue. I make it before last time, if you remember. I will share the link for you for the recorded sessions. The important thing now, all of you, to make the not homework, assignment, or the just enjoy your free time, drinking the pencil and just A3 paper, white paper, and draw the 3-phase separator with each detail you have it. Okay, when you're doing this, you will come next time with a bunch of questions. That will make it you better in drafting and reviewing B&ID. You got my points? Okay. Thanks you all. See you next time, inshallah.